Podcast. This is Mr. White,
And Mr. Sadler.
and today we're going to have fun with the Pythagorean theorem. When I think Pythagoras, I think fun.
Do you really?
I do. No?
The Pythagorean theorem is one of the only things that I can actually remember using after I got out of high school. I was setting up a tripod, and I knew the two legs, but I was just trying to set it up when I was creating my own satellite dish, actually.
Okay. I don't like Pythagoras for the Pythagorean theorem. I like Pythagoras because he actually, by ear, developed the diatonic music scale.
Oh,
And he was able to pick out which musical sounds were good and which ones were not good, and he was able to mathematically predict musical notes.
so he never did any of his work in Japan,
No,
right?
no. So on page 454, we're going to walk you through a few of these questions here and use the Pythagorean theorem.
All right.
So go ahead and get us started on number one.
So number one says a roller coaster at a 25-degree incline makes a sharp right turn as it descends the hill. The velocity of the roller coaster cart is 5 meters per second south before the turn. After the turn, the velocity of the roller coaster cart is 12 meters per second west, but is also pointing downward at an angle of 25 degrees. Ignore the downward angle. Okay, so A says, determine the change in velocity of the roller coaster using the vector diagram. Recall that V final minus V initial is identical to V final plus negative V initial.
Right. So
So subtracting is the same as adding the negative.
right, and so that's a lesson we learned in fifth grade
Right.
math. Adding negative numbers is the same as subtracting positive numbers. And so they tell me that the final velocity happens to be 12 meters per second west, and that the initial velocity happens to be 5 meters per second
North.
south.
Oh, right, south,
South.
but we're taking the negative.
And so if I wanted to know the negative initial, and I'm writing that because these are equivalent statements, then it would be 5 meters per second to the north.
Correct.
It wants us to determine the change in velocity using a vector diagram. Okay, so I've got my 12 meters per second
To the west,
to the west, that's VF.
and the 5 meters per second north.
This is VF equals, and I got to go 5 meters per second to the north because this is negative VI. And it wants me to determine the vector change. So if I had I should have a ruler when I do this, of course. There we go.
So if you had graph paper, you could use a protractor, or you can use the
Yeah.
math.
And so I could go ahead and measure these, assuming that I scaled this out to 5 and 12. But because I've done a little math in my life, I believe that this is 13
Correct.
meters per second. And it's some angle north of west.
25 degrees.
And it works out to be 25 degrees, huh?
Correct.
That's crazy. And so theta is 25 degrees. So once again, a protractor could help you measure that. I believe that's part C of this whole thing. Then it says determine the magnitude of the change in velocity of the roller coaster using the Pythagorean theorem. Okay, so your vector diagram is a very good place to start. So I know that if I'm calling this delta V, well, delta V squared is VF squared plus negative VI squared. And to find delta V, I'm just going to take the root of everything. So 12 squared plus negative 5 squared, that's square root of 169, which is exactly 13 meters per second. If I wanted to take this to the next level, I'll just do that right here. I know that the tangent of my angle here is the opposite side of this triangle over the adjacent side. So the angle is actually tan inverse of 5 over 12. And when I do that, I get negative 25, and that negative 25 is measured from 180 degrees. I misspoke earlier. This is not, that was a positive 5 there. I didn't want you to think I was cheating the math. The reason why this is a positive 5 is because it's pointing in the positive direction. So negative VI is a positive number.
Correct.
See if you can get your brain around that. 2 is an interesting question. Go ahead and read question 2 to us, Mr. Sadler.
All right, so it says, how would you answer question 1? How would your answer to question 1 change if you took into account the downward angle of the incline?
So that's particularly horrible. We would have to do some 3-dimensional, are you ready for this? Pythagorean theorem. I bet they didn't know that existed.
Right.
So space comes in 3 ways. Space comes in the up-down.
Right.
Space comes to the left-right. Space goes from the out and the in. And so in this particular case, we said it was moving to the west, and we had to talk about north, and then we had to come out of the page. And now we have 3 dimensions of space. Instead of x squared plus y squared is r squared or whatever, or a squared plus b squared is c squared, you have to add that 3rd term. So, because you don't like yourself, no, that goes away if I do that. A squared plus b squared plus c squared. And I won't even get into the trigonometry of this. This is just awful. So number 2 is terrible. Please don't do that to yourself.
Well, it doesn't say to do it. It just says that you'd have to solve it using that. So.
Right. That would be the method. So a long time ago when I was in college, I might have done that. What I would like you to do at this point is to really look at numbers 3 and 4. And it goes through some of the... 3 actually we might have just done for you, but go through the steps, take a look at that, and focus on number 4. Put the whole thing together. Please don't use a protractor. Learn how to use those graphing calculators. They give you very precise answers.
Well, and they should have done that in math class, too.
Well, you would hope so. So I believe that covers section 9. Signing off, this is Mr. White.
And Mr. Sadler.